Have you ever wondered how data travels through a network and why it's crucial to understand its flow? Welcome to the fascinating world of network traffic. Network traffic, in the simplest terms, is the movement of data across a network. It's much like the traffic on the roads we use every day. Cars represent data packets, roads are the network connections, and traffic signals control the flow of data. Just as a smooth traffic flow is essential for a smooth commute, the flow of data is critical for efficient network operation. Too much traffic, and you have a network congestion, similar to a traffic jam on your way to work. Too little, and you have an underutilized network, just like an empty freeway in the middle of the night. While the concept of traffic is simple, it's the patterns and behaviors that bring in the complexity. In road traffic, you have rush hours, alternate routes, and traffic rules. In network traffic, you have peak hours, alternate pathways, and network protocols. The curiosity of network traffic lies in its unpredictability. Just as you can't predict a sudden roadblock or an accident on your commute, network traffic can also face sudden spikes or dips due to unforeseen events. Understanding network traffic involves tracking the movement of data packets, monitoring their speed, and observing their patterns. This is where the concept of network traffic analysis comes into play. It's like having a traffic control center for your network, where every single data packet is tracked, monitored, and controlled to ensure smooth operation. So why is understanding network traffic so important? Well, it provides valuable insights into network performance, helps identify potential issues, and aids in making informed decisions for network optimization. In a world where data is the new oil, network traffic is the pipeline that transports this valuable resource. It's the highway that connects different parts of the digital world. Therefore, understanding its flow, patterns, and behavior is fundamental to ensuring a smooth and efficient data transfer. Just as understanding road traffic is key to efficient transportation, understanding network traffic is key to efficient data transfer. So, what exactly is network traffic analysis? Well, let's imagine you're a traffic cop, but instead of directing cars and pedestrians, you're overseeing a flow of data. Your task is to understand the patterns, the routes, the speeds, the heavy and light traffic periods, and to identify any potential bottlenecks or roadblocks. That's essentially what network traffic analysis is all about. At its core, network traffic analysis is the process of recording, reviewing, and interpreting the data flowing across a network. It's like the heartbeat monitor of the internet, giving us real-time insight into what's happening on our networks. This data can be anything from emails and web pages to voice and video data, all of which are transmitted as packets of information. But why is this important, you might ask? Well, understanding network traffic patterns helps network engineers maintain optimal performance and security. It helps identify trends, troubleshoot issues, and even forecast future needs. For instance, if you notice a sudden spike in traffic, it could be a sign of an ongoing cyber attack. Or, if there's an unexpected slowdown, it might be due to a bottleneck somewhere in the network. On the other hand, understanding regular traffic patterns can help plan network capacity and avoid overloads. For example, if you know that every weekday at 5 in the afternoon, there's a surge in video calls, you can ensure the network is prepared to handle it. So, in a nutshell, network traffic analysis is all about keeping an eye on the ebb and flow of data. It involves collecting and interpreting data to ensure the network is running smoothly, securely, and efficiently. Network traffic analysis is not just about problem solving, it's about problem prevention. It's about staying one step ahead of issues, ensuring that the network is always ready to support the demands placed upon it. Network traffic analysis, therefore, is the process of using data to understand and improve how a network operates. Why should we bother about network traffic analysis, you may ask? Well, it's like asking why we should care about the weather forecast. Just as the weather forecast helps us plan our day, network traffic analysis helps us manage and optimize our network's performance. Imagine network traffic as a busy highway. Without traffic analysis, it's like driving blindfolded. You wouldn't know if there's a traffic jam ahead or if a fast lane has just opened up. Network traffic analysis in this context acts as your GPS, guiding you through the network highway. One of the key benefits of network traffic analysis is that it helps identify bottlenecks. By studying the flow of data, we can pinpoint where congestion is occurring. This allows us to address the issue promptly, whether it's by rerouting traffic, upgrading hardware, or optimizing our network configuration. Speed and efficiency are the lifeblood of any network. Network traffic analysis provides valuable insights into how data is moving through the network. It helps us understand if our network is running at its full potential or if there's room for improvement. By identifying slow points and inefficiencies, we can take steps to speed up data transmission and improve overall network performance. But it's not just about speed and efficiency. Network traffic analysis is also a powerful tool for enhancing security. By monitoring network traffic, we can detect unusual patterns that may indicate a cyber attack. This allows us to take preventive measures before a full-blown security breach occurs. In a world where data is king, network traffic analysis is the castle guard, keeping an eye on the comings and goings of data packets. It's a critical tool for managing network performance, enhancing security, and ultimately ensuring that our network is running smoothly and efficiently. Network traffic analysis is not just a fancy term, it's a critical tool for any network engineer. So whether you're a seasoned network veteran or a newbie just starting out, understanding and leveraging network traffic analysis is crucial to your success in the field. Now, how does network traffic analysis work? Let's delve into the mechanics of this fascinating process, shall we? First and foremost, the process begins with data capture. This is where network traffic data is collected for analysis. The data can come from various sources such as routers, switches, or firewalls. This raw data, also known as packets, is the lifeblood of network traffic analysis. Think of it as the DNA of your network, carrying all the vital information about its health, performance, and potential threats. Moving on, once the data is captured, it's time for data analysis. This is where the raw data is dissected, inspected, and interpreted. Network traffic analysis tools take these packets and break them down into understandable chunks of information. They reveal the who, what, when, where, and how of your network activity. This stage is akin to a detective piecing together clues at a crime scene. The tools examine the data, looking for patterns, anomalies, and potential threats. Now you might be wondering what happens after the analysis. Well, that leads us to our final step, action based on insights. Once the data has been analyzed and the information has been extracted, it's time to act. This could mean addressing performance issues, countering potential security threats, or even enhancing network efficiency. It's like a doctor prescribing a course of treatment after diagnosing a patient. The insights derived from the analysis guide the necessary actions to ensure the network's optimal health and performance. But remember, the process doesn't end here. Network traffic analysis is a continuous looping process. It's akin to a vigilant watchman, always on duty, constantly monitoring the network, ready to act when needed. So there you have it, the mechanics of network traffic analysis in a nutshell. It's a systematic process that starts with data capture, moves on to data analysis, and culminates in action based on insights. But it doesn't stop there. It's a continuous cycle ensuring your network is always performing at its peak. As you can see, network traffic analysis is a systematic process that requires careful execution. What tools do network engineers use for network traffic analysis? Well, let's dive into the world of network traffic analysis tools, shall we? First up, we have Wireshark. It's like the Swiss Army knife of network analysis tools. Wireshark is an open-source network protocol analyzer that network professionals use to troubleshoot and analyze network protocols. It's like having X-ray vision into your network, seeing all the data packets as they travel across it. You can capture and interactively browse the traffic running on a computer network. It's a go-to tool for network engineers worldwide. Next, we have SolarWinds Network Performance Monitor. It's a powerful and versatile tool that allows for quick detection, diagnosis, and resolution of network performance issues. It can monitor and analyze network performance statistics for both routers and switches. It also generates dynamic network topology maps that can help you visualize the structure of your network. Another worthy mention is PRTG Network Monitor. This tool provides real-time information on network traffic and usage. It's an all-in-one solution offering a comprehensive set of features right out of the box. With PRTG, you can keep an eye on the entire infrastructure of your network and get alerts if anything goes awry. Let's not forget about Nagios. It's a robust, open-source network monitoring tool that can monitor systems, networks, and infrastructure. Nagios offers network traffic monitoring capabilities, alerts, and reports. It's a fantastic tool for spotting problems in your network before they become major issues. Of course, these are just a few of the tools out there. Depending on your specific needs and the size of your network, you may find other tools like Zabbix, Manage Engine Op Manager, or Cisco's NetFlow Analyzer more suitable. Each tool has its unique strengths and features, so it's often a case of trying a few out and seeing which one fits best with your workflow and requirements. With the right tools, network traffic analysis becomes a much more manageable task. So, equip yourself with these tools and master the art of network traffic analysis. Now let's look at a real-life example of network traffic analysis. Imagine a thriving e-commerce company that relies heavily on its online presence. Business is booming, but there's a sudden, unexplained slowdown on their website. Customers start complaining about slow loading times, and the company is at risk of losing sales, fast. Enter the network engineer, armed with the power of network traffic analysis. The engineer starts by collecting data, examining the network traffic in and out of the company's servers. They use specialized tools to capture packets of data as they travel across the network, analyzing their content, source, and destination. The initial analysis reveals an unusually high volume of traffic from an unknown source. This is a red flag. It could be a sign of a distributed denial of service or DDoS attack. A DDoS attack is when an attacker floods a network with traffic to overwhelm it and disrupt its services. The engineer dives deeper into the network traffic data. They isolate the suspicious traffic, tracing it back to its source. As suspected, it's a DDoS attack. The engineer then takes immediate action, blocking the IP addresses associated with the attack. But the work doesn't stop there. The engineer uses network traffic analysis to monitor the network closely in the aftermath of the attack. They look for signs of further suspicious activity and ensure the network is running smoothly again. The result? The website's performance improves dramatically. The loading times are back to normal, and customers can shop without any hiccups. The company's sales start to recover, and the crisis is averted. This case study is just one example of how network traffic analysis can be a game changer. It's a powerful tool in any network engineer's toolkit, capable of identifying and resolving network issues swiftly and effectively. As this case study shows, network traffic analysis can lead to tangible improvements in network performance. What does the future hold for network traffic analysis? As we embark into the unknown of tomorrow, we can expect to see network traffic analysis evolve in fascinating ways. One of the most anticipated trends is the increasing use of artificial intelligence and machine learning. These technologies are expected to play a pivotal role in reshaping the landscape of network traffic analysis. Imagine a world where AI systems can anticipate traffic patterns, identify anomalies, and even predict potential security threats before they occur. It's not science fiction, it's the future of network traffic analysis. Machine learning algorithms, with their ability to learn from data and improve over time, are poised to take network traffic analysis to a whole new level. They can sift through vast amounts of data, identify patterns and trends that humans might miss, and provide actionable insights in real time. In addition to AI and machine learning, we can also expect to see more integration between network traffic analysis and other IT systems. This means that network traffic data will be used not only to monitor and manage network performance, but also to inform decision-making in other areas of the organization. Moreover, as network traffic continues to grow in volume and complexity, we'll see a rise in the use of advanced analytics. These tools will help network engineers make sense of the massive amounts of data generated by network traffic, enabling them to detect anomalies, optimize network performance, and improve overall network security. And let's not forget about the cloud. As more and more businesses migrate to the cloud, network traffic analysis will need to adapt. This might involve developing new tools and techniques for monitoring cloud-based network traffic, or it might mean integrating network traffic analysis with cloud management systems. The future of network traffic analysis is exciting, with technological advancements promising to make it even more effective. As we stand on the brink of this new era, it's clear that network traffic analysis is not just about understanding what's happening on our networks today, but also about preparing for what might happen tomorrow. We've covered a lot today about network traffic analysis. We've delved into its curiosity, unpacked its details, and discussed its profound importance. We've also explored the mechanics behind it, the tools of the trade, and even dived into a real-life case study. Let's quickly revisit the key takeaways from our journey. Network traffic analysis, at its core, is the process of monitoring, reviewing, and interpreting the data sent and received within a network. This process is no mere task. It's an essential component of maintaining, troubleshooting, and improving a network's performance. We've uncovered the mechanics of network traffic analysis, and no, it's not all about staring at graphs and pie charts. It's about understanding the story that the data tells us, the story of our network's performance, its strengths, and its potential weaknesses. We've also walked through some of the most popular tools of the trade. From packet sniffers to network analyzers, these tools are the unsung heroes of network traffic analysis. They provide the data and insights that enable network engineers to maintain optimal network performance and security. We then transported ourselves into the real world with a case study showing network traffic analysis in action. The case study illustrated just how vital this process can be in identifying network issues, preventing security breaches, and making informed decisions about network upgrades or changes. Finally, we look towards the future of network traffic analysis. With the rapid advancements in technology, this field is only set to become more critical and more complex. But with complexity comes opportunity, the opportunity for more effective network management, better security, and improved performance. Remember, understanding network traffic analysis is key to managing and improving a network's performance. If you find this video helpful, please like, share, and subscribe to my YouTube channel for more informative content like this.